So I will start. So we will, as said, share the next lecture with Jaana, and we'll talk briefly about the European strategy in these comprehensive observations, and the key, of course, is to provide data for this towards sustainable development goals, as we are in the red zone in terms of climate change, for example, and nitrogen cycle, etc. So the society is using more resources that are available, and we don't even know yet all the influences of, for example, chemical pollution or atmospheric aerosol loads. So we need harmonized observations, and that's why we have several of these research infrastructures in Europe, operational and also developing. Okay, I don't need to go into this. We need to tackle the grand challenges, and we do it with observations. And we need to have this comprehensive way of co-locating the different observations. For example, Hytiala being the one where we have ICOS, Actris, and ELTER working at the same time. And of course, we need the ground-based observations, which we will talk briefly next, or we will mostly talk about ground-based observations. But in order to get the full picture, we need the satellite information that was explained by Larissa, and then we need the models as well in order to make prognosis for the future development of the Earth system as a whole. And each of these components need their connections with each other for validation, for example. And okay, the SMER2 is a good example of these co-located European infrastructures. I showed already this figure, and I think Jaana showed this as well. And then in the next step, I will talk about the infrastructure Actris, and Jaana will talk about the ecosystem observations in the infrastructure point of view. No need to go there. I've shown this already. This one as well. But let's go to this Actris infrastructure. So the acronym stands for Aerosols, Clouds, and Trace Gases Research Infrastructure, and it is an European scale research infrastructure, and it's this kind of distributed research infrastructure with contributions from different European countries. It includes ground-based remote sensing, for example. These are sun photometers looking at the sun. Then we have chamber facilities like this one, where we can do controlled experiments in controlled conditions and understand what happens, for example, in new particle formation or other processes. Then the Actris includes alpine in situ observations, like this is Jungfraujoch in Switzerland. Also Arctic observation sites. I think this is in Svalbard, if I'm not mistaken. It also includes LiDAR systems and laboratory facilities, and also observations in this type of environments with so in a way, in a pan-European way, all types of observations related to aerosols, clouds, and trace gases. And overall, the Actris capacity, it includes 135 atmospheric variables and provides 24 atmospheric data products. And the key there is to harmonize and provide data on atmospheric composition, atmospheric properties, and in order to understand what are the processes influencing the concentration. So what is the influence of industrial activities, forest fires, volcanic eruptions, or biogenic emissions, or emissions from the sea surface. So the long-term observations and harmonized observations can give us more insights into these trends and processes changing the atmospheric composition. And the points that we can use the ACTRIS data are connected to the climate understanding. So aerosols and clouds are short-lived climate forcers. Then there is a clear connection to air quality. So ACTRIS includes aerosol concentrations, but also, for example, ozone and NOx. And so those are air quality parameters. And then, of course, the comprehensive observations help to assess the health impacts when combined with data on human health. And the ACTRIS capacity includes in situ observations at the ground level, but also the ground-based remote sensing, which helps us to get to the vertical dimension. And then the fourth dimension, of course, is time. And the aim is to have the observations for the running years and years. So to have also the interannual variability, but also decadal variability. And this kind of data is needed in order to, for example, understand what are the implications, for example, of policies. So for example, removing sulfur from fuel has decreased SO2 concentrations throughout the world and in Europe considerably, and we would not know this if we would not have harmonized observations of SO2 in different parts of Europe. So you need harmonized observations to follow up on the improvements of air quality as well. Of course, you need to monitor also if something goes into the wrong direction as an alert system, but also for the long-term trend analysis. All right, I'm going to show all of this. So ACTRIS is actually the key thing for these research infrastructures is to provide support for the researchers, and one way of providing support is to offer different kind of platforms to visit and make your own measurements. So actually ACTRIS and other infrastructures are also offering support to make additional measurements. For example, in Hytiala we have several these called transnational access programs where anyone either from research community or from private companies or governments, they can bring their own instruments and compare against our observations. The ACTRIS also offers instrument calibration, different types of industry services. For example, one thing that was very active in ACTRIS was testing of filter materials during COVID-19 outbreak. So ACTRIS provided facilities to test how efficient are the different types of masks in filtering out the virus particles. Then, of course, the ACTRIS facilities offer training and education, and not all access have to be physical. So we also offer virtual access. So either virtual access to the data products themselves, or in the facilities where these data products are done. And the ACTRIS structure at the moment is that there is a European level. We have the central facilities. So the head office is going to be in Helsinki. So ACTRIS is an infrastructure that is not yet fully operational, but it will. It is now in the implementation phase, and it should be operational in 2025. It is already been decided that the head office will be in Helsinki, and next year we are waiting for the European Commission decision on establishing the head office and initiating this independent organization of actors. In the European level, we also have the data center. This is in Nilu in Norway. Then we have different thematic centers that are responsible for harmonizing the observations in different ways. So in situ measurements of aerosols, in situ measurements of clouds, in situ measurements of reactive trace gases, and corresponding centers for remote ground-based remote sensing. And then national activities and contributions to actors come from these observation sites like Pyytiälä, or laboratory facilities, for example, SEAM in Valencia, or Sapphire Chamber in Germany. So, or exploratory platforms like in Cyprus Institute is responsible for different types of drone measurements on board drone instruments. And in a European level, we have approximately 150 scientists and technicians, but then the bulk of the scientists are working actually in these national facilities. So there's almost 800 researchers then working on the national levels. So it's a wide set of people involved in actors. And this is the timeline. As I said, 2021 was establishment of the infrastructure, but this is now delayed for 6 months. So 2022, this will the official actors will, as a legal entity, will start, and by 25 it should be operational. If you look at, you can go actually to and see what the actress data looks like. You can go to actress.nilu.no and look at the different observation sites and how they are distributed in Europe. So you can search for the data, and there's also a source for near real-time data as well. And as I said, we offer also this transnational access. Actually, unfortunately, on Tuesday, one of the access programs ended open call, but there is also other opportunities open, so you can have a look at the access. But then maybe we go to Elter.
Yeah, thank you. Can I share my screen, Tuukka? It might be easier when I'm
okay.
I
will stop. That's fine.
Thanks. Okay. Should be okay now.
Yes.
Okay. Good. So let's continue with a kind of similar but different approach. So like Tuukka said, we have this European scale research infrastructures in different disciplines and different kind of focus areas. And I'm presenting now Elder, and I presume that I'm presenting also ICOS, right?
It's up to you, but that's fine with me.
Okay. Okay. Well, first, this ELDER. So ELDER is an acronym of Integrated European Long-Term Ecosystem, Critical Zone and Socio-Ecological Research Infrastructure. The long name means that there is actually 3 different research communities merging together and coming together to bring in the comprehensive understanding of how ecosystems function and how they develop over time, and how humans impact these systems, and how humans are also impacted by the ecosystem change. And it's filling a critical gap in the way of understanding comprehensively different challenges. And here is a list of the research challenges that ELDER addresses. So they are coming derived from the related European or global grand challenges. One is the biodiversity crisis, biodiversity loss, which is highlighted by European strategies on biodiversity and globally IPBES, intergovernmental biosphere biodiversity observation system, but also many other kind of legally binding directives that European scale are in effect. Climate change has been mentioned many times by myself and Tuukka as well. We have huge challenges in understanding and observing and also trying to mitigate the effects. And European scale, there is Green Deal and strategies on adaptation and Paris Agreement and so on. At the local scale and also continental scale, we have problems with pollution or eutrophication. So, for example, wastewater management and how that is affecting the downstream water bodies. Agriculture is important in that respect in Baltic area, producing a lot of phosphorus to the system and creating eutrophication, and that has consequences on the system, ecosystems as well. And then the socio-ecology might be not so familiar word for you, but that's overarching concept of understanding how the environmental protection and sustainable management of our natural resources, including water, soils, and biodiversity should be managed, and how human systems are effectively or ineffectively capable of doing that. So these are the challenges, and Elder wants to address them using this kind of whole systems approach, where we take the kind of combined understanding of all these different spheres, starting from the soils and the geosphere to hydrosphere, biosphere, social and human economic sphere, and then all the way to the atmosphere, how the ecosystems are reflecting the composition of atmosphere. So Elder aims at serving all these communities with its site categories that capture measurements at each of these spheres or scales. And the sites might be differing in their focus on different systems. There might be some that are focused on hydrosphere more than geosphere, for example, and some that are covering all of these components. And for example, Hyytiälä is one of these master site category sites that are addressing all these components. What Elder provides is the basic site infrastructure. It also provides clusters of information, not only its own observations on water or soils or the biosphere, but also the multiple other data sources like remote sensing or modeling proxies of ecosystem processes. And like Actris, we also provide user access programs to data and also the site access. We also have just recently now, I think it's opening or just now opened a transnational access call to Elder sites that are possible to apply for a research visit and using the facilities. The costs are covered by the travels and accommodation, and there's also some services covered by the projects to the visitors. So it's worth considering and having a look. One example of the whole system approach is shown here, which is unfortunately very poor quality, but it's from a recent paper by Martin Forsius et al. That took the whole system approach in practice and tried to simultaneously analyze the effect of climate change and biodiversity on the same land area. So how to take into account the conservation of biodiversity and also, on the other hand, the carbon uptake, carbon pools and storages and fluxes at the same time. So what would be the management options that maximize these two different challenges on the same land area. So here on the right hand side is the carbon pools, or the red areas are the ones where this can be maximized. Biodiversity looks a little bit different in spatial scale. And then here is the combined approach where both of them are simultaneously optimized or maximized in a balanced way. So this is kind of approach that would be facilitated or made possible with this ELDR approach. ELDR site looks like this. It might be, this is a aerial photo of alpine site actually, that is then having this kind of catchment that is defined area where the inputs, energy, matter and water inputs, and then the outputs are simultaneously observed. And then also the systems that are driving these inputs and outputs are measured at the scale of this site. ELDR has, I already mentioned that ELDR has this kind of modular structure or hierarchical structure of sites. Master sites are covering the most of the observations, and then regular and focal sites are covering some parts of the observations, and satellite sites are the least instrumented, but they still provide opportunities for scaling and ground proofing of these in detailed measurements of the master sites. And then the largest component is LTS-ER platform that is then including several of these different types of site categories inside it. At the moment, ELDR anticipates to have something like 200 sites into the process. They are here in these dots. In European scale, there's almost 500 sites listed at the moment, but we know that not all of them will be fulfilling the criteria that will be needed for standardized observation. So we anticipate that roughly about half will be possible. The services or products that ELDR will be offering to users are either related to the access to sites or access to data, both legacy data and the recently obtained data. Legacy data we have for some sites over 100 years, and that's quite unique opportunity to understand the long-term changes when you have a site that has been in operations since the early 20th century. We have in Finland, for example, Hyytiälä, that has been established in 1911. Tvärminne that has been established in 1903, I think. So there's more than 100 years of some kind of observations, and it's of course a challenge to harmonize and bring this data available, and that's what ELDR wants to do. Then we want to also produce analyses, create virtual labs and analytical tools to tackle the data, and of course harmonize and integrate the data products from various sources. And we want to build the capacities of people working at the sites for research project design or technology development, training of research managers and scientists for using different technologies. For example, ecosystem biodiversity research is a very different technology or methodology than analyzing fluxes. So there's quite a lot of training needed for providing this understanding of the whole systems approach. Then I talk here a couple of slides about the coverage of ecosystem observation sites, and ELDR is actually a regional network of international long-term ecosystem research network, ILTER, that has regional groups in East Asia, Americas, Europe, South Africa, and so on. And each of these regional groups has then member networks, and these are countries that are participating as members. And here you see that Europe is very populated. So most of the European countries are having at least some sites that are listed in this DIMES site data catalog. Japan is also very active. There's a huge number of Japanese sites that are listed in this metadata catalog, and also China at the moment is coming up very strongly. But what you see here is a huge gap in the former Soviet Union, Russian territory, where there's only, I don't know what this dot is, but it is a site that has been listing itself in DIMES. And if there are any of you that are currently running a site or hosting a site, I'm strongly recommending in going to the DIMES and looking at what is there, because it's a huge opportunity to bring visibility to your site. You don't need to join into anything concrete project or any, there's no requirements of regular updating or anything, but it brings visibility to your site. It would be wonderful to have coverage of sites also here, because there's of course many sites available there. And this last one on elder is the representativeness of these elder sites. So it's clear that the densest coverage, the greenest colors are here in the Europe, somewhere in North America, and then in Asia somewhere. But then there's a lot of gaps in less populated areas and less networked areas in Asia, Africa, South America, and also in Russia. And then the third one that is in this kind of environmental research infrastructure perspective important is this ICOS, integrated carbon observation system, that is providing data on greenhouse gases. And ICOS is already established as a legal entity. ICOS head office is in Helsinki, and it is already providing data products for the services. In the case of Finland, Anna-Lea Lohila from Finnish Meteorological Institute is the focal point of ICOS in Finland. And ICOS is, the name says, integrated carbon observation system. So ICOS wants to address the fate of anthropogenic CO2 emissions. It tackles the sources, so what is bringing greenhouse gases to the air, but also the sinks where the greenhouse gases are going, staying in the atmosphere or taken up by the ecosystems. And this is, of course, also a global challenge, well-recognized challenge by the IPCC and many organizations worldwide. And ICOS is providing a benchmark on the standardization of measurements and providing open data for the use of decision makers and researchers. So how to measure the emissions and sources and sinks? There's a variety of technologies in place, but one of the biggest success stories in the last 20 years has been the establishment or successful implementation of the eddy covariance method, and that's the basis method for ICOS observations. So ICOS ERIC is the European Research Infrastructure Consortium legal entity, and ICOS has 13 member countries at the moment, about 140 stations, more are coming every year, and about 80 renowned universities or institutes are hosting these stations. It's providing measurements at atmosphere and ecosystem and ocean stations. All data is openly available and free for everybody. And the countries that are currently listed are Belgium, Czech Republic, Denmark, Finland, France, Germany, Italy, the Netherlands, Norway, Spain, Sweden, Switzerland, UK, and Hungary, and Poland, which I think are not listed here. Poland is colored pink here. Spain is also pink because it came quite recently, but Hungary is the most recent one. This fall, Hungary is joined also. So ICO station network, the map you can see here, the blue dots are ocean stations, green ones ecosystem stations, and red ones atmosphere stations. And then there are a couple of them that are hosting both ecosystems and atmosphere stations, so combined observations of both the sinks and sources and concentrations in the air and the systems. One in Spain and a couple of them in Sweden and one in Finland. And here is the number of different types of stations: 38 atmospheric, 86 ecosystem, and 23 ocean stations. The ocean observations are also done using ships. So there are instruments that are hosted or located over passenger or freight ships that are going around the oceans and doing observations. And what ICOS aims to do is to operate highly standardized and high precision long-term observations. ICOS is very keen on providing support to policy and decision making and providing data products that are supporting common understanding of the trends and challenges in emissions and greenhouse gas sinks as well. ICOS has this kind of structure, so there is thematic centers for atmospheric observations, ocean observations, and ecosystem observations that are taking data from the measurement stations and then processing the data and providing all the data to a centralized carbon portal that then produces finalized data products and puts them into available repositories or storages for users. There's also central analytical laboratories that are providing calibration systems and for example C14 carbon 14 analysis for quantifying the emission sources, fossil sources. ICOS has a rigid standardization not only for the data but also for the stations. The stations require a labeling process where the applicant first expresses their interest to become a member. ICOS evaluates it in several steps, provides feedback to the station, requirements for constructing and upgrading, and then gives a label when everything is fulfilled. And the full labeling process takes several years in practice. So in these next slides, I don't go in details about the measurements, what they include. There's a long list of atmospheric and ecosystem and ocean measurements that are mandatory. Then there are some that are only recommended. So useful, but not mandatory for getting this label. Especially for the ecosystem measurements, the eddy covariance fluxes are the recommended or the only thing that is mandatory for them. And ocean air as well. And the carbon portal is available. You can search it, you can preview, you can download data from there. You can also use their tools for statistics and comparison and reach for some educational materials and synthesis report from this address. And yeah, lots of visible data objects, lots of downloadable lots of downloads. So it's widely used for researchers, but also for scientists. Here is how the data might look like if you download it from the data portal. And the data is used for many different things. One of the recent ones is the analysis of the drought, extreme drought that Europe was experiencing in 2018. The ICOS data was producing a whole issue in Philosophical Transaction of Royal Society B. You can find it, I think 20 papers came out from this analysis of the data and important analysis was done. Other example is the ICOS data in detecting the pandemic effects on emissions. Here is, for example, data from some cities, Helsinki, Berlin, Florence, and so on. And you can see clearly that the time when the pandemic hit in March, the emissions from fossil fuel traffic related emissions went rapidly down, and you can clearly detect when the lockdowns were done. I think this is all from ICOS as well right now. So I'm stopping my sharing and.
Oh, Jaana and Tuukka, thanks an hour on time. I think it's extremely useful for our students of our school. And now we have the possibility for at least two have an idea about something. I think it's best time.
Jaana, you want to say something about the whole ENVI landscape?
That one was missing. Okay, yeah. So we were planning to show you one slide that was now missing from the presentation, and it was about the European environmental research infrastructure landscape that has been putting together this kind of, thank you, Tuukka, this kind of ENVI community. And both ICOS, Actris, and ELTER, they all belong to this consortium or cluster of environmental research infrastructures that is, its aim is to collaborate as much as possible, even though all of these infrastructures have their own focus areas and their own niches in a way, their own methods. But there's a lot of commonalities, for example, in the data systems and user engagement and so on. So there's a lot of common work, and this European Union has been providing quite abundant funding for these communities in 3 projects so far, and hopefully it will be continuing in one way or another when the last one is ending. It's quite a long list of infrastructures that is participating, both from single domains and then those ones that are addressing many domains like oceans, atmosphere, and ecosystems, for example.
Yeah, and in a way, at first, all of these acronyms are very difficult to remember, and I don't even know all of them, but there's a lot of observational activity in Europe that contribute to different parts of the Earth system. I just want to show one additional, because in the title we also had the weather infrastructure. So this is WMO, Global Atmospheric Watch Network, and the same thing here is that Europe and US and is rather well covered, but there's gaps in Russia. But in our joint work with Pavel and others, we actually went through different activities in Russia as well as part of Pan-Eurasian experiment. And as Jaana said, we identified a lot of stations and good and relevant activities in different compartments, so cryospheric observations or atmospheric observations, biospheric observations. But it's not always easy to get access to the data or find the researchers who are working on these at these sites. So connecting these stations to DIMES or other way to get in contact with the scientists is very important. And this is part of this joint Pan-Eurasian experiment PEAKS.